Good morning, everyone. Welcome to our webinar today. So we'll start with a brief introduction as a video, and then we will start, inshallah, the webinar.
Over the years, humankind has been on the search for new technologies that simulate human intelligence in machines. Machines programmed to think and act like humans. In just the past few years, drones have become widely introduced and adopted by various businesses and governmental organizations around the world. Esbar provides a unique service in Oman. Since 2017, Esbar's forward-thinking technology has been applied across the nation, setting up a dynamic future for a wide range of clients in both the private and public sectors, providing complete solutions driven by revolutionary commercial and industrial technologies tailored to any business requirements. Our innovative solutions harness the power of artificial intelligence and drones to transform the way our clients carry out their operations with accurate and innovative technologies in different fields. Drones have been successfully integrated into surveying efforts to perform land surveys, photogrammetry, 3D mapping, topographic surveying, and more, capturing data up to 5 times faster than conventional methods. At Esbar, we will always bring you the latest technologies in the field of your work. We develop customized artificial intelligence-empowered products and solutions to address the complex needs of our clients. Using highly intelligent data management platforms, Esbar enables businesses to process, analyze, and deliver insights from aerial data accurately and efficiently. Adopting our latest solutions across industries provides a range of operational and financial benefits. Esbar helps businesses to overcome the most complex challenges. We develop and deploy our drones and AI-powered solutions to bring safety, reliability, and cost-effectiveness for all our clients. Esbar's vision is to be the leading drone and artificial intelligence-powered solution provider in the GCC, with a mission to help businesses and investors improve operational reliability and efficiency, enabling higher investment returns. Professionalism and dedication are at the heart of what we do. Our team of experts and highly trained technicians strive to deliver the very best of services and are invested in the success of every client project. Technological advancements are rapidly shaping the blueprint of how business will be conducted in the future. Businesses can, with no doubt, expect to see more process automation and efficiency, increasing productivity and helping you make better, faster decisions. Esbar.
So welcome again to our webinar. Okay, I'll start with a brief introduction about myself. So my name is Sara Al-Maziadi. I'm head of a new solution development here at Esbar. I have been here with Esbar for almost now 6 years. And through this time, I have been designing and implementing innovative technologies across different sectors, mostly for oil and gas and other sectors. And I'm delighted today to be co-hosting this session with my colleague Mohammed. Mohammed, please go ahead and introduce yourself.
Thank you, Sarah. Good morning, everyone. My name is Mohammed Hinai. I am a senior R&D engineer at Esbar. I have been part of Esbar for almost 2 years now, and I also play a role in developing and introducing new technologies and solutions to the oil and gas industry, in addition to many other industries as well in Oman.
Thank you, Mohammed. So before we start our webinar, please have there you will find the Abul on the screen, on the top of the screen, and please take a minute and answer it so we can know from which industry you are. And also through the webinar, please feel free to write your questions on the Q&A tab. We will address them at the end of the webinar, inshallah. And yeah, Mohammed, can you go to the next slide, please? Yeah, we'll start with a brief introduction about ISBAR. Maybe most of you are familiar with ISBAR, but this is a brief introduction. ISBAR was established in 2017, and today it stands as the leading provider of drone inspections and survey integrated with AI and IoT-based solutions. ISBAR is certified by both UK and Oman Civil Aviation Authorities, or CAA. We are always focused on helping our partner to enhance safety, reduce downtime, and optimize assets performance. And you can see that this is some of our partners and our clients from different sectors. And our services, to the next slide, please, Mohammed. So ISBAR services range from drones, AI, IoT, remote sensing, and software. And personally, really proud that all of these services are, the teams are located here in our office here in Oman. So this was like a brief introduction about ISBAR, and now we'll start with our main topic, which is the drone autonomous station, or drone in a box, all like refer to the same solution. And just to give you a bit of background on this research that we have done, and we started back on 2021. We start searching for such a solution. We reach out for many developer or vendors on such or similar technologies. We faced many challenges. Most of the challenge was that the systems on the market was not mature, especially for environment like Oman, where operational temperature is really high, and it is required to be deployed on the site with a certain minimum operational temperature. But after testing different systems, alhamdulillah, the system now is deployed already on the field, which is good. So why we are searching for such a solution? What is the goal, the primary goal for such a solution? Just imagine that you have like a drone that is enabled to operate 24 hours, 7 days through the year, and in a manner that you will set it once and you will forget about it on the site. This is like the main goal. This is like the dream for anyone with the drone operation going on. So it was a game changer to have such a system mature enough to be deployed at the site. Especially for like these fields where you need a continuous monitoring and continuous data collection. Yeah, so let's have an overview about what is the system exactly, what's the purpose of the system. So the system, the autonomous station or drone autonomous station, drone docking station, or as I said, drone in a box system, is designed to house and charge the drone. And also it gives you the ability to monitor and control and operate the drone remotely and automate this process. So having such a system will give you a lot of benefits. To just list some of these benefits is to have a quick drone dispatch, especially in high-risk areas or in a high-risk situation where time is crucial. Also, you will eliminate the need for a pilot to be existed on the site or near the dock itself. So you can have the operation fully remotely. Also, it will reduce the risk on the emergency situations where you will provide what we call real-time situational awareness, but without like exposing your personnel or your pilots to any danger. So this is like a few of the benefits you get from the drone autonomous station. There is a video on the next slide that will show you one of our units. And as you can see, this is the drone in a box or drone autonomous station. And you can see once the the canopy is open, but before the canopy is open or the system is open, the system itself will perform a pre-flight checklist. It will check the system from charging status, from the environmental situation, and then the drone will just be deployed to do the mission it have, and then it will go back center itself to start the charging and just be ready to the next operation. This is يعني in general, and now Muhammad will continue with you to dive in more details on this system. So Muhammad, go ahead.
Thank you, Sarah. So yeah, I'll be giving a brief introduction to the different docking stations that SPAR currently operates. I'll be starting with the short-range autonomous station labeled MISBAR 1. So this is like I mentioned, a smaller sized docking station for short-range operations. It's equipped with a multi-rotor drone. It has a very high environmental rating of 50 degrees Celsius with an IP56 and IP55 ingress protection rating for the dock and drone respectively, meaning it can operate in very harsh, hot and dusty environments. It's also equipped with internal cooling to keep the drone at a reasonable temperature during its charging and preparation for the next missions. It's equipped with automated smart charging, keeping the drone on standby at all times in case it needs to be deployed. It has an endurance of up to 45 minutes, depending on the environmental conditions, in addition to a charging turnaround time of 27 minutes, also dependent on the environmental conditions. It's equipped with an integrated weather station, so it's always aware of the weather conditions and the weather forecast prior to flight, and will allow or reject flight depending on the conditions. This is done through pre-flight checks, so it will check multiple different factors such as weather conditions, connectivity, and other automation procedures that will clarify whether the drone is able to fly or not, and it will only fly once all conditions are satisfied. It's also equipped with automated waypoint mission capabilities, allowing for the pilots or the operators to pre-program certain flight paths, which the drone can then automate independently during its operation. In addition to that, it's complemented with a set of AI-enabled features, allowing for real-time detection and reporting. So when it comes to the specific payloads of the drone, the first payload is the EO/IR system, referring to the electro-optics and infrared system. This is equipped with a thermal and visual camera. The visual camera has a 48 megapixel triple sensor layout, meaning it's equipped with 3 different cameras, one wide camera, one zoom camera, in addition to one telephoto camera with up to 112x hybrid zoom, and a 1800 meter laser rangefinder, allowing us to determine the distance between the drone and certain objects, up to 1800 meters in distance. And it also supports full color night vision as well. The thermal sensor is a standard 640 by 512 thermal camera with the 28 times digital zoom. It's equipped with a near-infrared auxiliary light for night vision as well, and has a temperature range of 0 to 500 degrees Celsius for measuring the thermal signature of various different assets. The system can also be equipped with auxiliary payloads as well, which includes a illumination kit, which is basically a dual spotlight for night operations. The spotlight is gimbal following, meaning it will follow the direction of the camera at all times, illuminating the area which the camera is pointing at. It can also focus on different objects and maintain a lock on them. It covers a wide field of view depending on the altitude, and also has a similar ingress protection rating of IP55, allowing it to operate in the same conditions as the dock and drone. Moving on, we also have a broadcasting kit. This is for audio broadcasting. This is a very valuable payload for whether it's emergency response or for security and surveillance. It has a maximum volume of 114 decibels, which is very loud relative to its means of operation. It also has text-to-speech capabilities, meaning the operator can remotely type in text, and then the drone will relay that in speech form through the speaker. And it has a broadcasting range of 300 meters, meaning it can broadcast from large distances and relay messages, even when it's not near the relevant subject. So moving on to the long-range autonomous station, which is labeled MISBAR 2. It functions similar to MISBAR 1, with the exception that it's larger and it's equipped with a VTOL fixed-wing aircraft, meaning it's a larger scale aircraft that can fly up to 3 hours, so it has an increased endurance and a maximum operational radius of 50 kilometers. It's also equipped with automated pre-flight checks and automated waypoint missions in addition to preset actions. It also supports AI detection, and in this case, it is ideal for linear asset inspections, such as pipelines, roads, power lines, and any form of assets that extend for long distances. When it comes to the payload, it is similarly equipped with the electro-optics infrared system, with a visual camera able to relay in real time a 1080p feed with 30 times optical zoom. It's also equipped with detection and identification of different assets and people. For example, in this case, it's equipped with a 6-kilometer human detection distance and a 15-kilometer vehicle detection distance. It also supports single and multi-target tracking for fixed flight inspections. And the thermal sensor, similar to the MISBAR-1 system, has a 640 by 512 resolution, equipped with a 28 times digital zoom. It's also equipped with human and vehicle detections of 1.7 and 5 kilometers subjectively, respectively. And it's equipped with a temperature measurement support as well. So moving on, we have a video of demonstrating how the autonomous station MISBAR-2 operates. So as you can see, the canopy opens at first, the drone is raised above the station, it is then rotated into the wind, the charging pads are disconnected, and then the drone will proceed to take off. Once the drone takes off, it will climb to its set altitude automatically, and then it will activate the pusher motor in the back to fly in a forward motion and proceed with its mission. So looking back at both stations, when it comes to operational workflow, they both share the same metric. It begins with the user remotely creating a automated flight plan from his office. He does not need to be located on site. He can then send this mission to the autonomous station. Once the mission is executed remotely, the drone will deploy and fly towards the asset, capture the visual data. So a pilot will set a pre-flight mission of certain waypoints. During this mission, the drone will fly, capture these waypoints, and capture any footage of the asset preset by the pilot, and then relay this in real time through a server to the user. It's good to note that this server can be remote or can be set up to be on premises as well. So it's, in terms of data privacy, it's fully flexible. And then anytime during the mission, the pilot can take over manual control of the aircraft in case an anomaly requires further investigation or the pilot requires to change the course of the mission for any reason. So moving to asset inspections, if we start with MISBAR-1, this is an example of an automation workflow associated with the MISBAR-1 short-range station. So the pilot would first begin by creating a flight path. He would create certain waypoints, and he would adjust and set the camera position for each waypoint such that it's pointing at a certain feature of the asset that must be inspected. He then sets detection thresholds. So for this example, we're doing a thermal inspection of a power line or telecommunications tower, for example. And we set the thermal threshold to 60 degrees Celsius, meaning that anything beyond 60 degrees would trigger an action to be taken. Which brings us to the third point. We can select an action to be taken based on the threshold which has been exceeded. And this includes multiple different actions that can be taken. So the drone can either automatically take a photo, record a video, or request manual takeover. Each of these actions can be done independently or simultaneously, depending on how the user would like to set it up. In addition to this, the drone would send a notification to the pilot, either through the platform, the software on his computer, or through an email, or even through an SMS message as well. So here are a few examples of assets which can be inspected using this specific automation workflow. As you can see, in this case, we can see termination bars having hotspots exceeding 60 degrees Celsius along these distribution lines, which will then be highlighted by the drone and then notified and then sent as a notification to the operator who's located remotely, and then he can take further action or perform any further assessments if required. So to summarize, what are the different applicable use cases for MISBAR-1, which is the short-range station, as I discussed previously? We can perform localized survey and mapping for smaller facilities. We can perform live flare inspections without interrupting the operation of the flare. We can perform localized flow line inspections within the facility as well. We can do telecommunication tower inspections, storage tank inspections, in addition to localized distribution line inspections within a certain facility. And finally, we can also do gas leak detection. So the auxiliary payloads in MISBAR 1 can be swapped out for a variety of different payloads. All of these can be adapted for certain use cases and utilized along with the autonomous station. So moving on to MISBAR 2. MISBAR 2, as I mentioned earlier, is a long-range autonomous station equipped with a VTOL drone for linear asset inspections, which is supported by its increased operational radius of 50 kilometers. And based on our operations, we have been able to confirm that we are able to cover up to 200 kilometers of pipelines per day. All of this data tends to become a bit overwhelming. So we import this data into ISBAR Engine's AI model, which is a custom developed artificial intelligence engine by ISBAR. And it allows us to detect and identify anomalies. So a bit more on ISBAR Engine. So ISBAR Engine is basically a fully integrated tool that allows us to utilize artificial intelligence to analyze data collected by these drones through machine learning algorithms. And it's equipped with 4 primary features. The first one is data integration. It supports, meaning it supports a variety of different data sets, followed by mission and flight management, machine learning driven anomaly detection, which allows us to identify certain anomalies such as oil leaks and damages, which I'll be showing you later on as well. And then finally, it can report all of this data in a comprehensive manner. And this can be done on a daily basis as well. So the kinds of assets that can be inspected using ISBAR Engine consist of wellheads, so we can detect foreign object damages or missing cellular gratings, flow lines, where we can detect leaks and sand coverages. In addition to the sand coverage, we can actually detect and calculate the amount of sand in tons that needs to be displaced to clear these flow lines. We can also inspect pipelines for leaks and exposed pipelines. Power lines, we can inspect for bird nests, which often disrupt the operation of these power lines, and also the pole top conditions, looking at any specific damages to critical features. And finally, we can also inspect roads looking for surface damage such as cracks and potholes, in addition to obstruction of the road, which can be any form of foreign object such as sand dunes coverage. So this covers the asset inspection part. We're now going to be moving on to the security and surveillance section of this presentation. So security and surveillance operates on a similar baseline to asset inspections. It performs the same functions, but in this case, we utilize artificial intelligence to detect and recognize whether they're people, boats, or any other specified targets such as cars and other vehicles. The actions that are taken upon detection are set by the pilot, so he can set a detection threshold. And this, similar to asset inspections, we can take a photo upon detection, record video, request for manual control handover, in addition to sending a notification to the pilot. So this is a quick video demonstrating how the security and surveillance system works. So as soon as a vehicle is detected or an asset, the operator who manages the drone autonomous station through the platform is notified via a web notification, as you can see. Once a notification is received, he can then remotely view the feed of the drone from his office. And then, as you can see, all the objects, whether they're vehicles or individuals, they can be identified and annotated and tracked during operation as well. So this is the main benefit of utilizing artificial intelligence. Along with these autonomous stations, it can streamline these operations and allow for fully automated detection and actions to be taken without the need for any human input. So moving on to another means of integrating these autonomous stations for security and surveillance. One way is to integrate them through Whiskers. So Whiskers is also a fully integrated solution developed by ISBAR. It is a asset tracking industrial grade IoT device. It utilizes various sensors and technologies in order to track an asset and detect any form of tampering with the asset. It's equipped with all of the sensors are low power consumption, meaning that they can last for extended periods of time. And all the nodes, which are responsible for detecting and tracking these assets, are customizable based on the nature of the asset and its required security measures. So how can these nodes exactly be integrated with these docking stations? These nodes, given that they are IoT-enabled devices, they can be connected to the drone. So in the case that a Whiskers node detects motion, a signal is sent to the autonomous station and it is triggered where it deploys the drone. The drone then mobilizes towards the asset and then follows the asset based on the position telemetry obtained from the node. While it's following the node, it can relay a live video feed to the user operator for further investigation, upon which action can be taken. This summarizes exactly just one of the many use cases that IoT devices and drones can be utilized. In addition to motion tracking, Whiskers nodes can also be used for temperature detection. So in case there is a temperature threshold exceeded within a certain facility or within a certain asset, the drone can automatically deploy and then perform an investigation, taking photos and videos of the asset in mind without any pilot input whatsoever. So to summarize the use cases for security and surveillance, like I mentioned earlier, there are multiple different use cases, and the setup for these systems is basically unlimited and up to the user to identify and define what exact solutions he would need for his assets. But to summarize it into 4 different areas, I would put it as security facility, so secure facilities reconnaissance, so looking for any intruder detection within these facilities. Also production facilities patrol, so any intruder detection or unsafe access during certain periods of operations can also be identified via these autonomous stations. We can perform perimeter control and geofencing for other forms of secure facilities for illegal access detection. And finally, it can also be utilized for emergency response. So like I mentioned earlier, in the case there is a emergency in a certain facility or asset, the drone can automatically take off once it detects that an asset is performing abnormally, and it can perform a flight around the asset and gather critical data within minutes of the anomaly occurring. So to conclude and summarize all the benefits and added values of these autonomous stations, like I mentioned earlier, these autonomous stations can eliminate on-site personnel requiring no human interaction within the facility. It provides improved perspective for inspections or for security missions. An aerial perspective is always more broad and informative when compared to a ground-based perspective. We also get increased operational efficiency. The drone can deploy within seconds of the pilot's input and relay critical data within minutes, which then brings us to our next point, which is quicker response time. Specifically in critical situations, quick response time can make a night and day difference in operations. And finally, we obtain a real-time relay with autonomous stations where multiple viewers can always monitor the drone at any time from any place, which is a very critical factor when it comes to important decision-making and situational awareness as well. All of these points contribute to a reduced overall operational cost, streamlining workflows in many industries, allowing us to advance certain missions and inspections to a level where we do not need any human input and automation can fully take over our operations. So this concludes the presentation. I hope everyone has found it informative. If you want to learn more about ISBAR, you can always follow us on our LinkedIn page. I will. You have the link also posted on the chat. In addition to that, I'll leave this certificate of attendance QR code. You can scan it in order to obtain a certificate for attending this specific workshop. I'll give it a few minutes and we can move on to the questions part. Okay, so if anyone has any questions, feel free to post them in the chat or the Q&A section, and we'll be ready to answer them.
It looks it was all clear, so there is not a lot of questions.
Yes, Saeed. Saeed, if you can type your question in the chat or the Q&A section, then we are able to answer it. So for when it comes to the maximum operating wind speed of the drones, they can operate at a maximum takeoff and landing wind speed of 12 meters per second. So that's considered pretty high for most industrial standards. Yes, so the inspection plan, when it comes to configuring inspection plan, it can be done on a routine basis. So the operator can remotely create a flight plan and can schedule this plan to conduct itself every 30 minutes. For example, you have a certain facility containing multiple tanks, and you would like to perform a routine inspection on these tanks every 30 minutes or every hour. You can program it to, for example, take off at 6:30 a.m., perform an inspection, land at 7, charge, and then after 30 minutes, it would then take off again and repeat the process continuously. This is also applicable for security and surveillance and for facility patrol as well. So there are two different methods where the artificial intelligence models can be integrated with the drones. So given that the autonomous station is a fully integrated system, it can be equipped with certain hardware that allows it to perform on-edge computing, meaning real-time computing. The operator can upload certain artificial intelligence models to the dock and to the drone so that the models run in real time. This is for real-time asset inspection, for example, like I mentioned earlier with the temperature threshold detection. It can also be utilized for people detection, PPE detection, and the amount of use cases and models that can be uploaded is not limited by the drone. It's mostly limited by the models that the operator can upload to the drone and to the dock as well. Does the drone have? Yes. So the drone autonomous stations have a multitude of fail-safe features. So in case of a disconnection between the autonomous station and the drone automatically initiate a return to home function, where to return and land in the dock. If there is no communication between the dock and the drone, that's a second layer of fail-safe. The drone will land in its alternate landing location. So the drones and autonomous stations are always programmed with alternate landing fail-safes, meaning that in the case that there's a complete disconnection between the drone and the autonomous station, it would land in a preset open area in order to prevent any further risk. This is also applicable for when the environmental conditions exceed a certain threshold that doesn't allow the drone to land within the dock. The drone can then automatically detect that and land within its alternate landing location. Yes, so like I mentioned, when it comes to the battery recharge, it is dependent on environmental conditions.
Sorry, just one note. Just if it's good to read the question so everyone know what is the question exactly.
No worries. All right. This question says, could you please confirm the drone's flight time and coverage range and the time required to recharge the battery? So the drone's flight time, depending on which drone you're talking about, for the short range system Misbar 1, it has a 45-minute flight time, give or take a few minutes, depending on the environmental conditions. Its coverage range for standard operations is 2 kilometers. It can be extended up to 10 kilometers with an 18-minute mission. For the long-range autonomous station Misbar 2, it has a flight time of 3 hours and a 50-kilometer operational radius, allowing us to perform much longer missions for larger assets such as pipelines and flow lines. And when it comes to battery charging, this is very dependent on environmental conditions, but for Misbar 1, it's within the range of half an hour, so 27 minutes. However, this can increase and decrease depending on the temperature. While the larger autonomous station is also dependent on various conditions, it usually has a turnaround time of 90 minutes for Misbar 2. How is data privacy and security handled when the AI models process sensitive industrial sensor data? So when we mention that we have certain models on edge, meaning these models are local to the autonomous station itself. They are not running online. So the models are running strictly on the autonomous station and on the drone. and relayed back to the user. Now, in terms of the means of relaying this data back to the user, this can be done through setting up an on-premises server, meaning the server is strictly located and accessible on-premises and accessible by the relevant personnel only. So the system itself is not connected to the internet, and it's simply connected to the user via a direct connection. In addition to that, another layer of security that can be added is to deploy air-gapped servers, which are completely offline. What is the periodic maintenance required for the system to operate properly? So when it comes to maintenance, these systems require minimal maintenance. They simply require on a monthly basis just to clean the filters for the air conditioning systems, and every couple months to perform a check on the drone itself, make sure its condition and structural integrity is sound. How many times can the drone be charged at the same station? The drone is not limited by a number of charges. The station is connected to it's connected to external power, so it receives power from an outlet, and it can charge as many times as required. In the case that there is a power blackout, the autonomous station is equipped with a UPS, which is an uninterruptible power supply, that provides it with 4 additional hours of operational time. Yes, so this question from the Q&A says, what charging mechanisms do the docking stations have? So the smaller docking station, the short-range station, Misbar 1, is equipped with induction charging, meaning that there is no direct contact between the drone and the dock itself for charging. It simply charges via an induction mechanism. Misbar 2 charges via charging pads that connect to the drone once the drone lands. And when it comes to the interchangeability and compatibility, each docking station is designed with certain drone in mind. There are also other docking stations that Ispar has worked with that are drone agnostic, meaning that they don't rely on a specific drone, but those are for specific use cases. And the ones we currently operate are present significantly bigger advantages in terms of compatibility between 2 drones and optimization of the function between certain docking stations and certain drones. So when you have a drone designed to operate with a specific docking station, it tends to operate more efficiently. And that is something that we managed to understand through our operations. So this question also asked, what is the maximum operating wind speed that the drones can operate? Like I mentioned before, the wind speed, the limit for these drones for takeoff and landing is 12 meters per second. What protocols or communication standards are most effective for integrating IoT drones into existing industrial systems? So a lot of systems, a lot of sensors within these industrial systems, which are IoT enabled, have a stream that can be connected to the drone, or a data pull link that can be integrated into the drone, and this can be copied into the platform, the management platform for these autonomous stations. And once they are triggered beyond a certain threshold, this can deploy the drone. In terms of specific details as to how this can operate, I can forward this question to our respective team and get you a detailed answer later on. So in terms of any specific questions about operational protocols, you can feel free to send an email to Ispar, and then we can get back to you with specific details about operation. The email is sent in the chat, info@ispar.com. Is it possible to consider recharging using solar energy for the drone station itself? Yes, definitely. The drone can recharge using solar panels connected to the input of the docking station. It is a use case, and it is a means of operation as well, designed in mind when deploying this autonomous station. The drone will always switch to its UPS power supply in case the power input reduces below a certain threshold, so there is no interruption in power delivery or operation. Does the drone station have an adequate fire suppression system designed to manage lithium battery or electrical fire incidents? Very good question. So these drones are equipped with very specific battery management systems and very advanced battery management systems. These case a battery and prevent any overheating to begin with. And there are a set of different fail-safes designed into the battery supply, which prevent these incidents from happening to begin. In addition to this, the housing of these batteries are designed to withstand impact and designed to withstand any form of abrupt impacts. So this prevents any incidents from occurring to begin with. How safe is the drone for operations in hazardous areas, and how can we avoid zones with high concentrations of flammable gas? So when it comes to operations, there's a lot of mitigations, risk mitigations that we take into account. We never operate above a certain facility containing these hazardous gases. The drone operates along the perimeter and outside the facility, maintaining a fixed distance between the facility and the aircraft itself. And this allows us to prevent any increased risks of associated with drones in these hazardous areas. In addition to that, the drone is equipped with a series of powerful cameras that can perform asset inspections from distance. They are designed with this in mind. If there's any further questions, feel free to ask. I'll give it a few more moments.
And at any time, please feel free to send us any questions through the email. We are happy to set even a meeting if required for more details. Okay.
Yes, I believe that's all the questions. So once again, thank you everyone for being part of this webinar. I hope you benefited from it. And like Sarah mentioned, if you have any further questions, feel free to email us and we can arrange a meeting to further discuss them in detail.
Thank you for having the time to attend this webinar. So thank you. And thank you, Mohammed, for this presentation.
Thank you very much, Sarah.